In section 5.2, we're going to study definite integrals. In 5.1, we calculated left ram, right ram, and mid ram rectangle approximations, and these were actually called Riemann sums. We did this very informally, so we're going to discuss a more formal construction of these areas, and we're not going to limit ourselves just to functions that are non-negative. So we're going to watch a quick video, and I'm going to put, well, it's not a quick video, it's about 10 minutes, and I'm going to put the closed caption on so that you can follow along at home. Okay, so there's a kind of a good discussion as to what the definite integral is. So what we're going to learn today is we're going to learn how to change from an integral notation to the limit notation of an integral. Okay, and there are some steps to do that. Okay, and the 4 steps outlined as follows. First of all, we have to find delta x, which is going to be b minus a divided by n. Step number 2, we have to find c subscript I, which is really going to be equal to a plus delta xi. And then we find the general solution by writing the area of those rectangles as a in summation notation. And then we find the exact solution by putting the limit as n approaches infinity. So let's take a look at an example. We want to find or write this integral as a sigma notation. So this really means the integral from 0 to 2 of x squared dx. Okay, so in step number 1, I want to find delta x, and delta x is equal to b minus a over n. In this case, b is 2, a is 0 over n, so delta x is 2n. Step number 2, I want to find my c subscript I, and c subscript I is a plus delta x I. So a is 0, delta x is 2 over n times I. So this is really 2i over n. And now I want to find my approximate area, and that's going to be our general solution. So it's going to be the Riemann sum from I equals 1 to n of my function evaluated at c. Well, my function is the function x squared. So I'm going to plug 2i divided by n in for x in my function. So that's going to be squared. And my delta x is going to be 2 over n. So basically, I just plugged my ci into my function, which was x squared, and I times it by delta x, which is 2 over n. And then the 4th step, I'm going to find the exact area by incorporating a limit. So it's the limit as n approaches infinity of what I had written in step 3. And there would be your final answer. So this would equal the integral from 0 to 2 of x squared dx. Okay, I want you to pause the video and give this next one a try. Okay, I'm hoping you had a chance to try this one. And this is really the integral from 9 to 25 of root x dx. So step number 1, I'm going to find delta x, which is b minus a over n, which is 25 minus 9 over n, which is 16 over n. Then in step number 2, I want to find c subscript I, which is a plus delta x times I. A in this case is 9 plus 16 over n times I. So now in step 3, I'm going to find an approximate solution or the general solution by doing my summation notation. Now I'm plugging this point into my function in place of x. So it's going to be the square root of 9 plus 16i over n times delta x, which is 16 over n. And step number 4 now, the exact answer is going to be the limit as n goes to infinity of I equaling 1 to n of the square root of 9 plus 16 I over n times 16 over n. Okay, sometimes we may have to convert integrals from sigma notation back to an integral. So for example, the interval -1 to 3 is partitioned into n subintervals such that delta x is 4 over n. Let c of k, so instead of using c subscript I, they use c subscript k, it doesn't really matter. Denote the midpoint of the kth interval. Express the limit as n approaches infinity from k equaling 1 to n of 3 c subscript k squared minus 2 times c subscript k plus 5. Okay, well, I'm partitioning from -1 to 3, so that's going to be the limits of my integrand. Okay, and these are where I'm plugging my point C of k in, so those are going to be my x values of my function. So my function would be 3x squared minus 2x plus 5, and would be the integral going from -1 to 3. Okay, this next example, we want to write this as a definite integral. Okay, so again, we know that this 3 over n at the end is delta x. So we know that delta x, the formula for delta x is b minus a over n, which is 3 over n. And we know that this is the inside part, c subscript I is a plus delta xi, so a has to be 5. So we know then that if I plug, I know first of all that these two things have to be equal, so I know that b minus 5 over n has to equal 3 over n. So the value of b would have to be 8. And therefore, my integral is going from 5 to 8. And this is c subscript I here, which is x in my function. So it's the integral from 5 to 8 of sine x dx. Okay, this is an actual multiple choice question from one of the AP practice tests, and they're giving us the integral, and they want us to write this as a limit. Okay, so again, I would find delta x, b minus a over n, so it's going to be 5 minus 2 over n, which is 3 over n. So right away, we can eliminate those two because delta x and those is 1 over n. Okay. And now I want to find c subscript I, and c subscript I is going to be a, which is 2 plus 3i over n. And if I plug that into my function, okay, it's going to be that my general formula is going to be the integral from I equaling 1 to n of 2 plus 3i over n squared times 3 over n, and then I would do the limit as n approaches infinity. Now they use k instead of I, it's the same thing, but if we take a look to see which one of these matches up, okay, the answer that matches up would be D because they're missing the 3 in answer for B. Okay, let's try this one here again. Let's get you to pause the video and give this one a try. So we want to rewrite this definite integral as a limit of a Riemann sum. Okay, so again, I got to find delta x. We should be getting a little bit better at this. B minus a over n is 3 minus 0 over n, which is 3n. C subscript I is a, which is 0, plus delta x I. Sorry, it's not 3n. It's a silly mistake on my part. This is 3 over n. So this part here is going to be 3 over n times I. And now I am going to substitute this in place of x in my function. So it's going to be the summation notation from 1 to n of e raised to the 3i over n. Delta x is 3 over n. And now you're going to put the limit as n goes to infinity, and there would be your final answer. Okay, one more to try. So again, pause the video and see if you can give this one a whirl. Okay, again, finding delta x is going to be b minus a over n, which ends up being pi over n. C subscript I is a plus delta xi, so it's pi over ni. And now I'm going to replace c subscript I into x, my function. So it's going to be summation notation from I equals 1 to n of cos of pi plus pi I over n. And then this would be the limit as n approaches infinity, and there would be the equivalent summation notation of this definite interval. Okay, that pretty much ends our lesson. So there'll be a handout for you to do, and there'll be a matching game that we'll play in class. So I'll give those to you in class, so you can give those a whirl and see how you do. In fact, your assignment in your handout is going to be this one here, numbers 1 to 4, and numbers 5 to 8. And the matching game is a game that we'll play in class. So give those a try and see how you make out.